Benford's Law? What is Benford's Law, and how is it relevant to the 2020 election? Can mathematics add clarity and transparency to our electoral process? Yes, it can, and I will explain how in 90 seconds or less. For those of us who are not math majors, I apologize. I'm not either, but let's go real quick down the rabbit hole. To make short order of a long concept, natural random occurring number sets tend to favor lower numbers as the first integer of a number. The number 1, in fact, is the favorite number of natural number collections, followed by 2, and then by 3, etc. All this means is that in a given set of random numbers, like votes that are being reported in random group sets from polling locations, more on that later, we should see 30% of the numbers collected have a 1 as the first integer. 17.6% of the numbers should have a 2, etc. So how does this help us when looking for fraud? Well, Benford analyses have been used to detect tax and election fraud for years, because when someone or something adds data at random, the data does not usually comport with Benford's law, and one can tell that the numbers did not come from a naturally occurring set. When all of this information is put into a graph, we should get a Benford curve, or at least something that looks similar. The p factor is effectively derived from the deviation from the expected curve. So if the p factor, probability, is too low, mathematically we know that the books have been cooked.